Hello friends, now I want to prove that n p suffix nx is equal to x into p suffix n single prime of x minus p suffix n minus 1 single prime of x. It is another recurrence relation for a Legendre polynomial pnx. Suppose if I want to prove left hand side is equal to right hand side, we need the help of generating function, what we have proved in the last videos. 2xz plus z square raised to minus 1 upon 2 is equal to summation of z to the power n into pnx, where n varies from 0 to infinity. Okay, now first I will expand the right hand side summation. I will replace n by 0. I can obtain z to the power 0 p naught x plus z to the power 1 p1x, z to the power 2 p2x, and so on. I will get z to the power n pnx plus 1. So you may call it as an equation number 1. Okay, now I am going to differentiate this equation. Equation 1 partially with respect to z. So what we will get? It is of the type x raised to n. Derivative of x raised to n is n into x raised to n minus 1. Raised to minus 1 upon 2 minus 1. But it is not x. That's why I want to differentiate all these terms. Derivative of 1 is 0. 2xz with respect to z is 2x is constant. Z with respect to z is 1. Plus z square is 2z. Right? So this is equal to, I want to differentiate right hand side term. Z to the power 0 is 1. P naught x is 1. It means first term is 1. Derivative of first term is 0. Plus z raised to 1 means z with respect to z is 1. So p1x is constant. Z square is 2z. p2x is constant plus 1. Plus, so n into z raised to n minus 1. So pnx is constant plus 1. Right? Simplify a left hand side term. So minus 1 upon 2. From these two terms I will take out minus 2. The remaining thing is x minus z. 1 minus 2xz plus z square raised to minus 1 by 2. Minus 1 means minus times of 3 by 2. This is equal to, I can write down as it is p1x plus 2z p2x plus 1 n into z raised to n minus 1 pnx plus 1. Okay, now I will call it as an equation number 2. Right? Okay, now I am going to differentiate equation 1 again. Or before that you can rewrite the same step in another form, because minus into minus is plus, 2 cancels with 2, x minus z, 1 minus 2xz, z square raised to minus 3 by 2 is equal to p1x plus 2z p2x plus so on n into z raised to n minus 1 pnx plus 1. So I will call this equation as a 2. Okay. Now differentiate 1, differentiate or again differentiate 1 partially with respect to x. Right? We get, I am going to differentiate this equation. Sorry, 1 minus 2xz plus z square raised to n. It means, so n into x raised to n minus 1. You will get minus 3 by 2 into derivative of this with respect to x, treating z as a constant. Derivative of 1 is 0. Minus 2xz with respect to x means 2z is constant, x with respect to x is 1, derivative of z square is 0. So this is equal to, right? Okay, I have differentiated left hand side. Now I want to differentiate right hand side with respect to x. So derivative of first term is 0 because it is constant. Derivative of second term is, so z is constant, I will write z as it is. Derivative of p1, it means you can write down p1 single prime of x, plus derivative of next term is z square is constant, p2 single prime of x, plus so on, right? Derivative of nth term, z raised to n is as it is, constant, p suffix n single prime of x, plus so on. Simplify from this term, I will write minus 1 upon 2 into minus 2. So z into 1 minus 2xz plus z square raised to minus 3 by 2. This is equal to z into p1 single prime of x, z square, p2 single prime of x, plus so on, z raised to n, pn single prime of x, plus 1, right? So now I want to multiply both sides by x minus z. Okay, so what you will get, you will see left hand side as well as right hand side I have to multiply. So what is the left hand side? So here minus into minus it becomes a plus. 2 cancels with 2. I am going to multiply both sides by x minus z. Z remains as it is. It means I will get z into, right? So right here z into x minus z, 1 minus 2xz plus z square raised to minus 3 by 2. This is equal to, I am going to multiply x minus z as it is, right? And I want to write the remaining terms as it is. So z into p1 single prime of x, so z square into p2 single prime of x, plus so on, z raised to n, pn single prime of x, plus so on. Okay, so I will get all these terms, right? So now you know the value of these two products from equation 2, right? So using equation 2, what is the equation 2? So we know that x minus z into 1 minus 2xz plus z square raised to minus 3 by 2 is equal to, right? So now I am going to replace these two factors by all these terms, right? Okay, I will write z as it is from equation number 2. So what I can obtain into the bracket, so I will get, so p1x plus 2 times of z into p2x plus so on, right? So you will get from equation 2, so what you will get, plus 1 n into z raised to n minus 1 pnx plus so on, right? So I have replaced the value of this is equal to, right? How will get from equation 2? Now I want to multiply x into all these terms. This is equal to x into, right? So z p1 single prime of x, right, as it is, z square p2 single prime of x plus so on, z raised to n pn single prime of x plus so on, right? So minus times of z into all these terms, z into p1 single prime of x, z square p2 single prime of x plus so on, z raised to n pn single prime of x plus so on. Okay, now I want to equate the coefficients of z to the power n. Okay, equating the coefficients of z raised to n from both sides. We get, okay, I want to collect what are the coefficients of z raised to n. Multiply z into first term, you will get the coefficient of z. When you multiply z into this term, z square, coefficient of z square, next coefficient of z cube, and so on. When I multiply z into this term, z raised to n minus 1 into z means z raised to 1 into z raised to n minus 1 means z raised to n. That is the coefficient of coefficient of z raised to n is n into p n x. Okay, this is the coefficient of z raised to n. From the left hand side, when I multiply z into next term, I will not get a coefficient of z raised to n. That's why I will ignore all those terms, these terms as well as next n plus 1th term, etc. Right? And similarly, now I want to multiply x into first term. So x into p1 single prime of x is the coefficient of z, coefficient of z square. What is the coefficient of z raised to n? I hope you will get this is equal to x into, so this term, pn single prime of x minus, right? Now I want to multiply z into z square. I don't want to z square. Z square into z cube. I don't want z cube, right? So when I multiply this term, so z raised to n into z means z raised to n plus 1. So that's why I want to multiply z into its previous term. What is its previous term? Z raised to n minus 1 p suffix n minus 1 single prime of x. That is the coefficient of z raised to n. Okay, now I am going to write p suffix n minus 1 single prime of x. Right? I hope this is the required equation what we want to prove. So this is another recurrence relation for the Legendre polynomial Pnx. Thank you.